Hello everyone, welcome to my channel. Today I am going to show you something really exciting, how to build an intelligent system that can extract answers from complex documents like PDF using advanced AI techniques and using LangChain. We will be diving into text splitting, embedding generation, vector databases, and creating a powerful RAG pipeline. So RAG means retrieval augmented generation pipeline using Google Gemini model. So let's get started with this. So first of all, we have to peep install all the libraries that we are using. So first of all, that is LangChain, then PDF for PDF reading, then Google Gemini Gen AI, and then our vector database that is Files CPU. So let's start running the code. So So these are all these the import. So whatever we are using in our code, so these are all the imports. So let's run these also. So the first one is PDF loader. So it will load the PDF that is character text splitter that we will come into in this video. And files that is vector database. Then we will be creating a retrieval chain, stuff document chain, Google generative AI that is Gemini then prompt and all the things. So this cell has been run. So now we have been using this PDF name barometer.pdf. So this is this PDF barometer.pdf. You can use any PDF of that. So like this is of 26 pages. This consists of. So you can load by this by PDF loader and then loader.load. So by this you can get load this PDF. So after this, let's check the length of the document. So it's 26, right? As I shown you. Then what is this recursive text splitter? So as we know, the document is very big, right? Right. So by character text splitter, it will split the documents. So the chunk size that is 500, it means the one chunk will consist of 500 characters. Then the chunk overlap means the 100 characters will be overlap from the ending of the last chunk and the beginning of the first and the beginning of the another chunk. So the by splitting this, we make sure that by making chunk overlap, so we make sure that it doesn't get any split. So it is like there will be 100 character overlap between consecutive chunks. Okay, so this ensures that important context isn't lost between chunks. Right. Then we are text splitter dot split document. So this applies the splitting process to the input documents that is stored in. So this will be stored in that is stored in docs. So resulting in a smaller text chunk that will be stored in documents. So now let's just see how the data is coming in documents. So like I was taken off 10th. So this is the data like this. Okay. So now let's check the length of the document. So it is 491 because we have put the chunk size of 100. So it will be maximum of 500 only. You can put anything. It's like trial and basis error. Okay. So now what is this? So you have to get the Gemini API key. You can Google Gemini API key and you can get the Gemini API key. So what I'm doing this is like I'm storing that keys in Google Colab secrets. So anyone cannot see our key. So it's a very good practice to do this thing. Okay. So now we are going to import generative AI embeddings. Okay. And so these generates embeddings that is for vector representation of text. So it will convert the our text into number. So it will be useful for that. As we know, no one can understand the English in model. So we have to first convert that into. It will be better if we convert into number. So we will be using the model that is embedding 001. And here we have passed our Gemini API key that is coming from this, and that is coming from our secret key. So if you don't want to write this code, so the whatever the key you are getting, you can print here on double inverted commas, right? So after this we are loading our LLM, that is Gemini AI. So that is chat Google generative AI. So this initializes the large language model from Gemini for generating responses, and we are using model that is Gemini 1.5 flash. So and this is our API key, so you have to put API key here also. Now we are creating a FIRES vector database. So FIRES is a Facebook AI similar search similarity. So it is a library for efficient similarity searches. So this creates a vector database from the documents that we have loaded up upper. So it creates a vector database from the documents and by adding this embedding. So that embeddings that we have called here, right? So by them using the previously defined embedding model, right? As we have created that, so we have to create a retriever. So this converts the vector database into retriever, so that allows querying the database to find relevant documents based on the similarity. So whenever we are invoking something chain or something asking the question, so whenever we have to retrieve something from our database, so the retriever will be very useful whenever we doing some similarity and that thing, right? So this is our template. We are giving a template instructions to our Gemini, our chatbot, that you are a PDF document expert specializing in extracting accurate answer from complex text. Utilize the provide context to deliver precise and concise answers. Provide a well-informed and detailed answer based on the context. So we are the context will be passing, that is our document. Okay. So now this is our prompt template. So we have to give some that the prompt that we have defined here. So we have to give this. So this method creates a prompt template from a series of messages. The first one is system template. So we are providing the system the instruction that you have to follow. So we have passed the template. So this is the thing we are providing to the system, right? Then the human. So human will be giving input. So the human method will later be replaced. So it will be replaced by the actual question or input, we can say, that is provided by the user. Okay. So now we are creating a stuff document chain. So this creates a chain that handle processing of document using the specified LLM and prompt template. That is the LLM, that is Gemini, and prompt, that is this. This is the prompt that is coming from. Now we have to create a retriever chain. So retriever is like retrieving the that we have stored. So chain and retrieving. So this integrates the document processing chain with the retriever. So it forms a RAG pipeline. So the RAG chain will first retrieve the most relevant document chunks and generate a response based on those chunks. Okay. So now let's start. So by this our chatbot has been created. So now let's start questioning to the chatbot, right? So I have first questions like what are the five pillars of corporations. So if we print the full results, so it will show us like what are the context and all that thing. So let me show you the one thing. Like if I print directly results, so it will give us the whole thing like from context also, like from page 8 we, so from where he gets the information, so from this PDF page 8, so then from page 6, page 3, page 7, and then after that he will give us the answer. So now let's fetch directly the answer. So we can fetch answer like results, then answer as it is the list only. So we have got the five pillars are like trade and capital, then tech, innovation and technology, then climate and natural capital, and health and wellness, and the fifth one is peace and security. Okay, so now let's make it perfect like chatbot only. So what I have done here is like inputting question. Okay, so first I tell you the flow how this is working, right? Okay, so whenever we give an input to this, so it will be like it will be going to chain reg underscore chain. So here our retriever will be there, right? And from chain, so LLM will be called, and from the prompt, so the prompt will be given. So based on this, okay, so based on this question it will retrieve from these documents, the document that we have created. So based on this it will be retrieve the similarity, the what are the similar from the whole PDF, it will retrieve from this. So it will be retrieved from this, and this question will be giving to the prompt, so LLM. So in this in the LLM this will be given, and in context the retriever that retrieve the most relevant information that has been provided here, and then the that generates the answer. So I hope you get how the flows is working on this. So now let's make perfectly like a chatbot only. So I have created a while loop here, and whenever user exit, then exiting. So let's run this. Okay, so now we have two questions questioning. So like I'm asking this question only, what are the five pillars of global corporation? So he has given the five pillars. So I first tell you from this only, like these are the five pillars of global corporation: trade and capital, innovation, technology, climate, natural capital, health, wellness, peace and security. So this has been given today. So now the next question is like from this I am giving you like from 2021 to 2022 the flow of goods are a share of GDP increased by. So this is how this chatbot is useful. You, if someone is asking you the question, so you cannot reading the whole PDF. It's like oh, so it is of 26 pages, right? But if there are more pages, so you can't be reading all the pages and getting the answer. So let's ask this question only. So I have this question here only. So he has given from 2021 the goods or flow of goods has set of GDP increased by 10% only. So this is how this all works. So this is the beauty of we have created this. So if you get the flows in upcoming videos, we are talking about more about this. Here also we can add uh, history also and there are many different we can provide we can evaluate our chain also like he is giving right answer or not and there are more of these things it is a basic good thing what we have done today. Okay, so and that's a wrap. Today we have taken a deep dive into building a powerful RAG pipeline using Google Gemini's model, from text splitting and embedding generation to creating a system that can extract answer from documents like PDF. I hope you find this tutorial helpful and that you are excited to apply these techniques in your own projects. So if you enjoyed this video, make sure to give it a thumbs up and subscribe for more AI and machine learning content. If you have any question or if there is anything you would like to see in future videos, drop a comment below. I had love to hear from you. Thank you for watching and I will see you in the next one. Thank you.